Alright guys, my explainer problem for week 10 says astronauts on planet X have initiated the intergalactic war of species with the native Martians after the astronauts repeatedly refused to stop performing experiments on planet X. You are Jimmy, an intergalactic soldier who has been separated from your squad, who is now pinned down under the watch of 2 alien observation posts, each housing 1 trio of Martians. In order to win the space war and save humanity, Jimmy will need to take out both of the observation posts that his squad can move.
Alright guys, so to visualize what we have going on here, I drew a picture. So basically you have your squad or Jimmy's squad pinned down behind a rock that they're using as cover from these 2 watch posts that have Martians in them with weapons. And important later, one of the towers has some conveniently placed gasoline barrels underneath.
Alright, so Jimmy's plan is to drive a Jeep into the gasoline barrels to blow them up and then jump out a safe distance away from the explosion. And then he's going to use the weapons from the watchtower to take out the second watchtower before they can take him out. So we need to work out the following aspects of Jimmy's plan. Alright, so first, using our knowledge of heat engines and efficiency, we need to calculate how much fuel Jimmy needs to pump into the Jeep for Jimmy's Jeep to be able to make it to the first tower, given some mileage per the Jeep. So to do this, so I'm not going to go into detail because it would take very long. But I'm just going to rather give like the starting step for each problem, or each step in the problem. So to find the how much gas we need, we would use the formula for efficiency, which we covered during the course, which is basically work out divided by work in. So we would calculate the work out outputted by the Jeep engine, and then calculate the work put into the Jeep engine and see what the discrepancy is. And then we would convert that work into, or see how that work relates to units of fuel, and then we would get some amount of fuel that's the minimum fuel needed to get to the tower. And then, of course, Jimmy's going to jump out a couple feet before, and the Jeep will hit the gas and blow up the tower. All right, so now that we have the first tower taken out, before we get too ahead of ourselves, let's first calculate the impact speed we need to be driving at to ignite the gas, actually. So Jimmy's basically going to try to convert the Jeep's kinetic energy into thermal energy by colliding with the barrels. So we need to calculate how fast the Jeep needs to be going on impact to actually ignite the gas. So given some ignition temperature of gasoline, we're basically just going to use conservation of energy as it was used in a previous explainer I did for the course, which was converting kinetic energy in a car crash into heat absorbed. Or not converting rather, but seeing how initial energy in the form of kinetic energy turns into heat absorbed as energy final. So breaking that down will give us something like this, which is 1/2 mv squared is equal to mcat, and then we can just isolate for velocity at a certain temperature, which is the ignition temperature, and then we can find out how fast we need to be going. All right, so after that, so Jimmy's going to grab a rifle from the first tower, and he needs to take out the second tower now. And basically, so the atmosphere on planet X is much thicker than on Earth. So sound travels pretty slowly through it, so we need to calculate the time Jimmy will have to take out the second tower with the sniper before they hear the initial explosion. So basically, to reiterate, the sound is going to travel very slowly from the first tower to the second tower. So Jimmy will have some time where these guys don't know what's happening while he can take them out with the sniper. All right, so to calculate this, we basically just use velocity is equal to distance over time, but we're going to rearrange it for t. So we get t is equal to d over v, and then following suit with another explainer we did early in the course, or I completed earlier in the course, where we calculated how long it would take for an echo to bounce off the bottom of a lake. We're going to calculate the time it would take for a sound wave to travel from here to here, and we would just break down that formula in regards to the sound wave specifically, and then we'd get that value for time. All right, so after Jimmy has taken out has taken the first shot, so basically Jimmy is really good with the rifle, and he's only really going to have a problem taking out the full second tower if all of them have sniper rifles to return fire with. If the 3 Martian soldiers have equal chances of deploying with a sniper rifle, a shotgun, or an assault rifle, we would like to find out whether a microstate of 3 snipers or a macrostate of 3 snipers is more or less or equally as likely as a microstate of a single soldier having a sniper. So again, I'm not going to actually do this, but to figure this out, we could make like a chart with symbols, this being sniper, this being shotgun, this being assault rifles, and we can calculate all the possible outcomes. So the macrostate would be if all three people in the squad have a sniper. We could call it a sniper squad, similar to how if all the cards in a royal flush or a specific hand, we call that macrostate a flush. So we calculate how likely that macrostate is compared to the likelihood of each individual soldier having a specific weapon. All right. So then following that, after Jimmy reunites with the squad, after he's taken out the second tower, they see an ambush in the distance. So basically, Jimmy's going to call for air support now. And if the space station that's going to deploy the air support is directly opposite the group's position on the planet, so basically I drew a picture for this. So if Jimmy's squad is over here and the air support carrier is over here, so kind of at the end of the pole, how long will it take for the air support to reach the squad? Again, this falls in line with an explainer from earlier in the course that I did. So basically in this case, the centripetal force that's at play here is gravity. So we can set centripetal force or mass times acceleration equal to gravitation, or Newton's gravitation law. And then breaking that down, you can get a value for period, or how long it would take for the satellite or the air support to go around the planet completely. But since this just has to go around half the planet, we would just take this and divide it by 2. And that would give us how long Jimmy has to fight off the invasion before air support arrived. All right, so after air support has arrived, they decide to deploy a sound blast that will rupture the eardrums of the Martians, because Martians have no eyesight and see using echolocation. So if you make them deaf, Jimmy will be able to win the fight. So in order to disable the Martians' hearing, should the sound wave be played at a higher, lower, or the same frequency that the Martians' eardrums naturally vibrate at? So this is just a quick conceptual question about resonance. So from resonance chapters covered in this class, we know that resonance is when we're operating the same frequency as a natural frequency. So the waves can superpose and reach a much higher amplitude and cause them to vibrate harder, in a sense. So in the same way that you would sing at the same frequency that a glass is vibrating at to break the glass, you would need to operate at the same frequency of the Martians' eardrums to rupture their eardrums most efficiently. All right, that's about it for the problem, guys. Hope you enjoyed. Bye.